Hi. In the next 15 minutes, I will present hacking Jenkins. Jenkins is a famous and widely used application in the world. In last year, I spent several weeks to studying the source. So this is the story for that. I will introduce the Jenkins, the routing mechanism, and how to abuse them to a pre-auth remote code execution. Hi, I'm Orange from Taiwan. I'm a security researcher in DevCore and now focusing on application security and zero-day research. And also a speaker, CTF player, and a bug bounty hunter. I'm the team captain of HITCon CTF. We won the second place in DevCon CTF twice. In application security, to take control of a server is more fun for me. So I love to find remote code execution in particular. Okay, here's the outline today. We first introduce the Jenkins and its architecture, especially the routing mechanism. By understanding the mechanism, we then start our main topic. In this talk, I will introduce two bugs. One is the access control bypass, and the other is the sandbox escape, including the idea, root cause, and how to exploit them. By training these two bugs, we can get a full pre-auth remote code execution. And the last, after I release my research, more and more researchers start focusing on Jenkins. Some of their findings are worth to mention and make the original exploit more reliable and elegant. Based on the original exploit and their finding, I will also release the whole exploit tool on my GitHub. So first, what is Jenkins? Jenkins is the leading CI and CD service in the world. CI and CD are the continuous integration and continuous delivery. In software engineering, the CI and CD are the best practice for developers to reduce routine works. When there is a little change on your code base, the CI and CD can build, test, and deploy the software automatically. To help developers check, is there any problem on the new change? And why Jenkins? Because Jenkins is the most well-known CI and CD service in the world. It's powerful, easy to use, and hacker-friendly. According to the Debian ecosystem report on 2018, Jenkins held about 60% market share on CI and CD applications. So for hackers, Jenkins is the battlefield that everyone would like to take control. If someone takes control of the Jenkins, he can get amount of source code, credential, or even control the Jenkins node to access the corporation intranet. And according to the Shodan, there are about 80,000 public Jenkins on the internet. Compared to the IoT, it's not a huge number. However, every Jenkins contains a lot of private secrets of the company. There are also several botnets are targeting Jenkins. The botnet exploit the known vulnerability and install their crypto miner. According to the research from Checkpoint, the miner group has earned about $3 million US in the last year. Apart from them, there are also large corporations expose Jenkins on the internet. In 2017, a security researcher found a public Jenkins instance on Snapchat. He could log into their Jenkins with any valid Google account. Once he logged in, he gained access to the private source code and the ability to execute arbitrary command on remote server. The researcher reported the bug and got $20,000 from their bug bounty program. So does the Microsoft. They also expose Jenkins on the internet. Okay, common attack vectors. The most common attack vector is the dictionary attack. And there is a very hacker-friendly feature called script console in Jenkins. If you have a valid login credential, you can use the script console to execute arbitrary Groovy script. That means you can execute arbitrary command on remote server. The next is to use known vulnerabilities. Yes, all the critical vulnerability before are the deserialization bug. However, we are not talking about the deserialization today. There are too many people focusing on that. We need a new attack vector. From the first article targeting the Apache Common Collection Library since 2015, the Java security steps into a new era. More and more people try to find more and more deserialization bugs in the world. It's hard to fix the deserialization bug in a manner. Jenkins used the blacklist to prevent from deserialization bug. However, everyone knows the blacklist is never a good idea. So, as you can see, there are lots of bypasses. Once the bug has been fixed, someone will find another gadget to make the Jenkins vulnerable again. This is the initial patch to fix the deserialization bug. You can see it just broke the gadget of Apache Common Collection Library. The previous patch has been bypassed quickly. Jenkins enhanced the blacklist. It broke more gadgets to prevent the Jenkins from the ZRMP gadget. Okay, it has been bypassed again. Jenkins blocks more and more gadgets, including the LDAP gadget. Yes, the bypass has never been ended. So Jenkins is so angry that rewrite all the serialization protocol to a new HTTP-based protocol. So there is no deserialization bug in Jenkins anymore. This is a good decision, and it works perfectly. In fact, there is no more remote code execution vulnerability since 2017. In order to discover new attack vectors, I decided to review Jenkins. Here is the scope I have reviewed: the Jenkins core, stapler core, and default install plugins. Stapler is the web framework used by Jenkins. All the routing mechanism, method invocation are done by the Stapler framework. From the review process, I got 7 CVEs. Today, I will introduce 2 of them. One is the code execution through the craft URL, and the other is the sandbox bypass in script security plugin. We start analyzing the Jenkins from the configuration file. According to the Java EE specification, the configuration is in the web.xml. From the configuration, we know Jenkins maps all the URL to a single servlet. This servlet is the Stapler framework we mentioned before. The core idea of Stapler is to automatically assign URLs to for your objects, creating an intuition URL hierarchy. The left side shows your code. So OOP lets you model your concept straightforwardly into classes that refer to each other. Through reflection, Stapler assigns URLs to your application objects. The root of your application object gets the root URL of /. The object you can access with method root.getObject would be assigned to the URL /project. In this way, your object model directly turns into the URL hierarchy. If it's still hard to understand, you can just imagine. In order to provide developers more flexibility, Jenkins used a naming convention to translate the URL dynamically. And here is the naming convention rules. Jenkins first tokenizes all the URL by a single / and begin from the root objects as their entry point to match the token one by one. If the token matches a public class member or a public class method correspond to following naming conventions, Jenkins will call the method or use the member as next object recursively. For a simple example, Jenkins translates this URL into following sequence of methods. We call this sequence of methods as the name method trend. With a proper understanding of the dynamic routing, let's go to our main topic. The first bug is the code execution through the graph URL. Actually, from my point of view, this is not a code execution vulnerability. It's just an access control bypass, which bypasses the overall read permission in Jenkins. The routing mechanism provides developers a lot of flexibility. So what's wrong with that? From my research, there are two problems based on this naming convention. The first is the hierarchical object problem. In Java, every class is the subclass of the class object. So every object in Jenkins inherits the method from object, such as the method getClass and the method toString. The interesting thing is the method getClass also matches the naming convention. So we can invoke some Java internal methods during the method chain. We construct the following URL to abuse the dynamic routing: getClass, .getClassLoader, .getResource, .getContent. Let's explain one by one. The method getClass matches the first naming convention rule and returns a java.len.class object. The getClassLoader is the method on the java.len.class object and also matches the first rule. So we can also call that. And the method getClassLoader returns a classLoader object. Okay, the same idea. The method getResource matches the second rule and returns a URL object. The last is to call the method getContent to read the file content. Okay, hope you have a better understanding on this calling convention now. The second problem is the whitelist bypass. The default access control list in Jenkins is very strict. Without a valid credential, you are limited to a few whitelist paths and cannot read any information. As we mentioned before, the dynamic routing, before, you know the logout prefix maps to the method do logout. So let's try to bypass the URL whitelist. We use the search function as our example. The path /search is not included in the whitelist URL prefix. So without a valid credential, you cannot use this function. Jenkins will return a 403 forbidden to you. However, what if there is a whitelist method returned a search object? If we begin from a whitelist object, and then every member in this whitelist object refers to a new object. So our work is to chain the object layer by layer until the object we want. So we start from the path /security_real_m. It's a whitelist URL, so it's always accessible for us. The method returned a security_real_n object. And then we look into the security_real_n object to see is there any interesting methods we can chain together. Okay, there is a method getUser under the object security_real_n. So we then look into the user object again. The user object extends the class abstract model object, and there is just a method getSearch under class abstract model object. As the user object use the user object as our proxy, we have bypassed the whitelist with the cross-reference object and call the search function successfully. We can search anything with no authentication required now. Did you feel that this bug is just like solving a math? You need to chain objects and objects to reach the dangerous invocation. It's very interesting. However, although we can bypass the URL prefix check, most developers check the permission before the dangerous invocation again. So even we can find an object reference to the script console. Without the run script permission, we still cannot do anything. Even so, this vulnerability can still be recognized, can still be considered as a good stepping stone to bypass the first access control list and chain other bugs. After I find this vulnerability, I am always thinking about how to maximize the severity. This is just an access control bypass. We can bypass the authentication required on other bugs to escalate the severity. We have trained this bug into several vulnerabilities, but it is not enough. Our goal is to find a pre-auth remote code execution. Yes, I did it. So the next is the remote code execution story. So first, let's introduce the pipeline. The reason why people choose Jenkins is that there is a powerful pipeline feature which makes developers more easier to write their own script for software building, software testing, and delivering. You can suppose pipeline is just a powerful language to manipulate Jenkins. In fact, pipeline is a DSL built with Groovy. DSL is a small language focused on a particular aspect of a software system. So pipeline is a small language based on Groovy. In order to check whether the syntax of user-supplied pipeline is correct or not, Jenkins provides an interface to do that. You can just think, if you are the developer, how will you implement this syntax error checking function? You can just write a AST parser by yourself, but it's too tough. So the most easy way is to reuse existing function or existing library. As I mentioned before, pipeline is just a DSL built with Groovy. So it must follow the Groovy specification. If the Groovy parser can deal with the pipeline, script without errors, the syntax must be correct. The code fragments here shows how Jenkins checked the pipeline. Here, Jenkins validates the pipeline with the method pass class. It should be noted that this is just a AST parsing. Without the execute method, any dangerous invocation will not be executed. So we try to pass the following Groovy script on our local environment, but we get nothing. From the view of developers, the pipeline can control Jenkins. It must be dangerous and require a strict permission check before every pipeline execution. However, this is just a simple syntax validation. Without any execution method, it's just a AST parser and must be safe. I have the same thought when the first time I saw this validation. What could be wrong? However, the meta-programming flashed in my mind. So what is meta-programming? Meta-programming is a kind of programming concept. The idea of meta-programming provides an abstract layer for programmers to consider the program in a different way and make the program more flexible and efficient. In general, meta-programming is write programs that operate on other programs, such writing programs by the compiler, preprocessor, or interpreter. When we are talking about the metaprogramming, we usually classify the metaprogramming into the compiler-time metaprogramming and runtime metaprogramming, according to the scope. Today, we focus on the compiler-time metaprogramming. Compiler-time metaprogramming can operate the program during the compiler time. There are several cases, such as the macro expansion in C language. You can generate a 2 gigabytes file by just a small C program. Another showcase is the template in C++. Template is a feature of C++ that allows functions and classes to operate with generic types. It means that you can assign the data type later, and this is all done by the compiler. The following code shows how to calculate the Fibonacci number by using the compiler. From the assembly language of compiled binary, we can make sure the result is calculated at compile time, not runtime. Pipeline is a DSL built with Groovy, and Groovy is a meta-programming friendly language. Compiling or parsing is a hard work with lots of difficult things and hidden features. So my idea is to find, is there any side effect we can leverage? So we start to read the Groovy manual to find something interesting. And we find an interesting annotation. Its name is AST test. This is the copy-paste from the Groovy manual. Performed a station on the AST. Is that what we want? This is the sample code from the manual. The phase is the compiler stage, and the value is the Groovy closure source we want to execute. We rewrite the sample in our local environment. Here we execute the command touchpoint. Yes, cool, it seems to work fine. And I thought we are in the right way and almost won the game. However, while reproducing on remote, the server responds an error. The error is unable to resolve class blah, blah, blah. What the hell? With a little bit digging, we find the root cause. This is caused by a plugin pipeline shared Groovy library. In order to reuse the function in pipeline, Jenkins provides the feature that can import customized library into pipeline. It is loaded before every pipeline execution. So as a result, the root cause is there is no corresponding library in class path during compiler time. How to fix the problem is easy. You can ask the server admin to remove the plugin, and then you can get code execution without errors. Yes, it's too late. And doesn't make sense. So we need to find another way. We continue reading the manual again. We find another annotation, grab. By reading the manual, we know grab is the Groovy built-in dependency management. It can help programmers import the library which are not in the class path. By diving into more about the grab, we find another interesting annotation, the grab resolver. It can define which repository to be searched. If you are smart enough, you would like to change the root parameter to your malicious website. And this works perfect on both local and remote. So now we believe we can make Jenkins import any malicious library by grab. However, the next problem is how to execute arbitrary code. We dive into the Groovy core to see is there anything we can leverage. During the research, we noticed an interesting method. Grab checks a few special entry points to install some additional services. Among them, the runner service interests me. By looking into the implementation of runner service, Here we see load class that new instance. Does it mean that we can call construct on any class? Yes, we can. So we can create a malicious jar file and put the class name into the runner service file. And we can invoke the constructor and execute arbitrary code. So let's try all together. First, we write a Java program and put our malicious code in the constructor. Here we pop a shellback. Yeah. We compile the Java and put the class name into the file org.codehouse.groovy.plugin.runners. Then we pack the jar file and move it into the web directory. The last step is to trigger the Jenkins to import our malicious file. Our exploit disables the checksum and set the load parameter to our website. Once the grep has downloaded the file, the runner service will load our Java class and execute our malicious command. Okay, we have a demo video here. Let me check the video. Oh, yes. Okay, so this is the demo video. The exploitations toolbox, the access control bypass, and the sandbox bypass into a pre-auth remote code execution. So this is the Jenkins. In the default installation, you need a username and password to do more things. And if you try to access the /user/admin, you will show a folio sweep forbidden and redirect back to the login interface. But we can use the security real end to bypass the access control check. Okay, so we bypass the URL prefix check. And now we use the sandbox as bypass. This is the POC. And yeah. Yeah. Okay, and then we open a terminal. Yeah, and listen a poll on 12345 to wait the shellback. And we ask you the exploit success. Yeah, it's back. Yeah, it's the demo video. Okay. Thank you. After Jenkins fixed the vulnerability, we did a little survey. There are about 75,000 public Jenkins in the wild. And this is the version list. If the Jenkins enable the overall read mode, it's vulnerable to our remote code execution. If it doesn't, but it's version on the 2.138, we can still train our dynamic routing vulnerability to make it vulnerable again. With our roughly survey, there are about 45,000 Jenkins we can hack. Okay, the last part. We will talk about the evolution of the exploit. The access control bypass was fixed in the December last year, and the sandbox escape was fixed in the January. After I post the blog about the access control bypass vulnerability, several researchers start focusing on Jenkins. Among them, the Zero Angel discovered a more universal entry to reach the syntax validation. And based on the discovered entry, the web pen test find another sandbox escape way on that entry. The original entry I find is based on classloader.pass class. It's a low-level interface and requires the meta-programming to get code execution. However, the new entry, which found by Zero Angel, is based on a higher-level Groovy interface. And that interface supports more features than original one. So with more features, the web pen test could break the sandbox easily. So with the growth of the evolution, we can now training their finding to a more reliable and elegant exploit. The red part is the access control bypass, which found by me. And the central part is the new entry, which discovered by the Zero Angel. This entry is more universal and supports more features. And the last part, the web pen test could get code execution by just a Java constructor. So in the new control, this new entry point, it don't need the metaprogramming. Okay, so here is the repository on my GitHub. I will push the code later. Okay, here's my contact information, and you can check my Twitter to know the latest information. Please let me know if you have any further questions. This is the end of my presentation. Thanks.
Thank you so much, Aaron. Do we have any question in the floor? Nobody? Yes. Okay, last round of applause for this almost awesome presentation.
Thank you.